Welcome back to the Data Analyst, your go-to place for understanding statistics, data science, and time series analysis in simple terms. In this video, we are diving into autocorrelation function, often called ACF, a key concept in time series analysis. We will cover what autocorrelation is, how ACF is calculated, how to interpret ACF plots, calculation of ACF, perform ACF in Minitab. So if you are ready to master another important concept in time series, let's get started. Let's start with the basics. Autocorrelation measures the correlation of a time series with a lagged version of itself. In simpler terms, it checks if past value in a time series can predict future values. It helps answer questions like this. Is today's temperature similar to yesterday's? Does this stock price follow a regular pattern over time? If the answer is yes, autocorrelation is present. Autocorrelation is the correlation between observation of a time series separated by a time lag. The autocorrelation function is a statistical tool that calculates and plots autocorrelation of a time series at different lags. For example, lag 1 compares each value with the one just before it. Lag 2 compares each value with 2 steps back, and so on. ACF help identify patterns, seasonality, randomness, and the order of an autoregressive model. Let's see how to interpret an ACF plot. This is the sample ACF plot. So vertical bars represent correlation value at different lags like lag 1, lag 2. Dashed horizontal line represent 95% confidence interval. Bars beyond the line indicate statistically significant autocorrelation. Bars within the lines suggest randomness or no autocorrelation. Notice how the coefficient is high at lag 1, lag 2, and lag 3. In terms of the month, if I have to say, then high positive correlation for January, February, and March. We will focus on the points that lie beyond the yellow region as they signify strong statistical significance. Importantly, make sure your data doesn't have missing value. Otherwise, the ACF will fail. This is the formula for calculate autocorrelation at lag k. So yt is value at time t, k is the lag, y bar is mean of the series, and rk is autocorrelation at lag k. Use autocorrelation function when you want to identify time series pattern or dependencies. Use ACF when you are choosing model like AR, MA, or ARIMA. Use ACF when you are checking if residuals are white noise after fitting a model. Let's see how to calculate autocorrelation function manually. So this is our example. So these are the y value 2, 3, 5, 7, 9, and 10. So what we have to do is first we have to calculate mean y bar. So 2 plus 3 plus 5 plus 7 plus 9 plus 10 divided by 6 equals 6. So our mean value is 6. So next step is we have to arrange our data like this. So in first column we arrange our yt value 2, 3, 5, 7, 9, and 10. So the next column we should have to put yt minus 1. So when it's come to yt equal 2, there is no previous yt value. So we don't have yt minus 1 for yt equal 2. So let's look at yt equal 3. So when it's come to yt equal 3, there is a previous value that is 2. So we have to put 2 into yt minus 1 box. So our third column is yt minus y bar. So our y bar value is 6. So our yt value is, first yt value is 2. So 2 minus 6 equal minus 4. That is how we calculate yt minus y bar. So we have to calculate all the value, but I'm not going to tell how to calculate all these values. So now you have idea how to calculate yt minus y bar value. So our fourth column is yt minus 1 minus y bar. So we know yt minus 1 value. So when it's come to first row, we don't have yt minus 1 value. So definitely there is no yt minus 1 minus y bar value also. So let's look at second row. So in second row, we have yt minus 1 value equal to, and our y bar value is 6. So 2 minus 6 equal minus 4. So that is how you have to calculate yt minus 1 minus y bar value. So our fifth column is multiplication of third column and the fourth column. So you have to get the multiplicate value. As example, look at second row. So our yt minus y bar value is minus 3, and yt minus 1 minus y bar value is minus 4. So multiply together, minus 3 multiplied minus 4, it is 12. So our last column have yt minus y bar square value. So yt minus y bar value, let's look at the first row. That is yt equal to, and in here we got yt minus y bar value as minus 4. So square of that value is 16. So we have to put 16. Likewise, you have to calculate all the values. And after that, get the total of fifth column and the last column. So we got yt minus y bar multiply yt minus minus y bar and get the sum of all these value, and it's 29. And the summation of yt minus y bar square equal 52. So add the calculated value into our formula. So it's 29 divided by 52 equals 0.5576. So our autocorrelation at leg 1 equals 0.5576. This is the data set, and I put here yt, and 2, 3, 5, 7, 9 and 10 are the values. So what we have to do is go to stat and then click time series and then go to autocorrelation. Then you can see this kind of window, autocorrelation function window. We have to put yt into series box. Then we have to mention number of legs. You can mention any number of legs. I will use 5 and then click OK. So this is the output results. As you can remember, this is the first autocorrelation function value for leg 1, 0.5576. And when we manually calculated that value, also we got 0.5576. So it's same. And these are like 2 value, like 3, like 4, like 5 values. And let's see our graph, autocorrelation function graph. And here you can see our legs. These bars didn't cross our margin. This is the margin, red margin here. So we can say that there is no autocorrelation because these bars stay within the boundaries. They didn't exceed that boundaries. So therefore we can say there is no autocorrelation.